Hey folks, your guy Garrett here, and this is the beginner programmer. This is in fact the introduction to the beginner class. So if you're the raw, never programmed, or maybe tried, dabbled a little bit and just became overwhelmed, this is the video and the website that'll clear it all up for you and turn you into a programming god. Now, I don't know if you came here from the web page or if you just found this video on YouTube, but if you found it on YouTube, you may want to pull up the accompanying article, it's at KickAssProgrammingSchool.com under Courses, Foundations, and Start Here. There'll be a link in the description. Some people learn better by reading, some by hearing and seeing. I'm giving you both methods, and to be honest, both are better. So the information, I'm not just reading what's on the web page here. This is all new information. Well, there's going to of course be some parallels, but this is new. I'm not just looking at that page. And plus, while the web page information is brief and to the point, in this video, I'm free to give you a little bit more insight and information. Now, I don't know what made you decide to learn programming. I found there's a few different reasons. The biggest one is people want to be game programmers. Another one is that people hear that you can get a pretty good job without having to get the 4-year degree. And others that a job at Google just sounds wicked cool. So, no matter if you have, let's cover all of these, but so let's look at the gaming first. If you've got the next great idea for Fortnite or Angry Birds, you're just not going to be able to jump right into that. That's not the place to start. Even Mona Lisa wasn't Da Vinci's first piece, and Einstein, he worked a shit job for years before and after his miracle year. You can't jump right into your big piece without having a good foundation. Programming can be easy, but it also can be challenging. I have literally at times, when I hadn't thought things out right, worked for weeks on something, and as the end started coming into sight, realized that I had made a mistake 2 weeks earlier and now had to go back and try to patch that fix in. And to be honest, this just makes your code look like crap, makes it hard to work on, hard to debug, and if it's on a really big project, can just ultimately make the project unmanageable. So you need a good foundation to start with, no matter how good your idea is now. And that's what I'm here to do. I'm not just going to throw some abstract code out at you and hope you can remember to use it when the time comes. Instead, I'm going to show you how the process goes, from the concept of a program to writing, debugging, adding patches, right up to fully functional shit. In other words, I'm going to show your brain how to light up and think like a coder. See, we were talking about games before, and most games are written on game engines, not in the general purpose languages. And most companies have an in-house proprietary game engine that they use. Now, just to give you an example of what a game engine does, you know about the z-axis, right? There's x is left and right, y is up and down, and z is forward and backwards. Well, to mimic the way that we see in the real world, if you move something on the z-axis, that is, move it, say, further back, the object has to move a little bit more towards the center. It has to get smaller, and the color saturation goes down, which makes the colors look more washed out or grayish. So when you're designing your game, you don't want to have to stop and think about all of this shit every time something moves on your screen. And you also don't want to run into the problem where in one scene it happens a little bit differently than in a different scene, because then the consistency between scenes doesn't seem real to the player's mind. So instead, you want to build it just into your game engine, and every time you move an object, your game engine will take care of all of those functions: smaller, centered, and washing out the colors. And the designer of the game doesn't have to worry about the physics of the real world or the physiology of the players. Now, like I said, this is a fundamental class. This is going to be the beginnings, things that you're going to need to know no matter what kind of programming you're doing. It's not a game. But if you are dead set that you want to program games, there's a ton of free game engines out there. Wikipedia has a great list. Just be careful of the rules. There are some free. There are some that are only free if you don't use it commercially, i.e. make any money from it. And I know of at least one that is free for up to the first $100,000 in profit. It's not a bad profit right there. So there's a lot of different rules, and they're all different. I'll probably make an article or a video about choosing between them, and maybe even do some projects using different ones, but that's not, well, by the time you're seeing this video, maybe it's already there, so check the list. Now another reason a lot of people are getting into programming now are because you've heard that you can get work, good paying work, without the 4-year degree. And you can get paid very good money too. You do have to hustle a lot, especially in the beginning. Be quick, be flexible. Living near a major city helps. Now, again, I think you should go through my fundamental courses here because it's going to help you out a lot. But if you're just dead set on, I want to get the job as fast as possible, then you should consider going out and learning to be what they call a front-end programmer. So you need to learn HTML, HTML5, which is new and improved HTML, CSS, and then JavaScript. That should get you the foundation that you need to be able to get work. Now, if you continue your education and you learn SQL, that's SQL, it stands for Structured Query Language. That's for accessing databases. Then there's PHP and Python, both of which can help you put that database information into your web pages. And lastly, if you learn to do this on Linux operating system and using the Apache web servers, then that's going to take you. You basically will be then what they call the full stack web developer. But like I said, that first step: HTML, HTML5, CSS, and JavaScript. And to be honest, only JavaScript is a programming language there. HTML is a formatting. It basically just, when you want to have a bold font, that's what HTML is used. You put the letters in there, but then you have to put the keys in saying, this is in bold, this is in italics, this is in this font, and make web pages that way. CSS is a way to put a whole bunch of descriptors, so you can say it's in this font, this color, and stylized in bold. You can put that all into one descriptor, even the font size, and give it one title. Then you can use that across multiple web pages so that all your web pages are consistent with each other. And when you decide to want to make a change, you can change it once in the CSS file, and it makes a change go all the way through all of your web pages. Now, while it may seem that we've covered most of the programming work out there, this would be far from true. All around you there are computers. In fact, if you're seeing this on a desktop or laptop computer, you're in front of at least 3 computers, maybe 4. Yeah, there's the Intel computer that we all think of as the computer. Your keyboard has its own computer inside it, as does your hard drive and probably your monitor. Now, while your PC or your smartphone are general purpose computers, these other devices only have one purpose. So they're often called dedicated systems, or more often called embedded systems. And they're all around you. Your telephone, camera, your car, airplanes, vending machines, TV, your TV's remote control, washer, dryer, microwave, thermostats, intercontinental ballistic missiles, jets, the Mars rover, all have these types of systems in them, and somebody has to program all of this. Then too, there's all those companies that you have an account number with. Amazon, the IRS, the electric company, phone company, cell phone company, your bank, credit card, your doctor for your medical records, cable company, if you use one of those grocery shopping cards, your Hulu account, your internet account. All of these companies have a database that you're in, and somebody has to write that database program. And then, of course, there's accessing the information when you call or you walk up to the teller or the cashier. They have to be able to pull up your account in a usable format and be able to access all that information. Again, programmers all have to write this stuff. And all of these, even if you were to work for, say, Verizon and for AT&T, they both have systems that do basically the same thing, but they each write their own. And these are programs that are constantly being upgraded, so they have full-time programmers working for them, as do any of these large companies. And now there's a new brand of programmers out there called data scientists. And data scientists basically look through huge amounts of usually unstructured type of information and try to find patterns in it. Like Netflix uses this type of programming to make recommendations on what movies that you might like. So if you give the Avengers a thumbs up, it looks through its database at all the other people who gave that a thumbs up and other movies that they gave a thumbs up to. And the more matches you have with those other people, the more it thinks you're going to be in that same group. This is why you do not want to let somebody who is a big fan of romantic comedies have access to your account, because you're going to be coming up getting recommendations of, the Princess Diaries or whatever. Now, on the dark and evil side of this is, and I don't know that this literally happens, but things like this happen, where a grocery store figures out that if they put a sale on pasta sauce, then their sales of pasta go through the roof. So they can, with a lot of fanfare, on the end of the aisle, put a big pasta sauce sale going on, and then quietly on the down low in the background raise the price of all the pasta. Kind of so the sale is meaningless. Maybe they make extra money. Now, it may seem with all of the amazing things that you can do with computers and how they help us in our day-to-day life that they have to be super complicated, but they don't. In fact, computers can really only do these 5 things. Input and output data. While they have it, they can manipulate that data. They can make decisions based on that data. And then they can do repetitive tasks really, really fast. Super fast, thousands of times per second fast. Now, inputting and outputting data, you'd think keyboard, mouse, monitor, but it can also be that red scanner that they use at the grocery store. It could be the radar on your car, and then the braking would be the outputting of data when it senses something getting too close. So it can take a ton of different forms. Do repetitive tasks. Showing your character running in a game screen is really just showing a series of pictures really quickly on the screen over and over again. It's that manipulate data that I left intentionally vague and make decisions based on data. It's going to give us a lot of wiggle room. That is where all the magic happens. And that's what I'm going to show you in the next couple of videos, and then in the first actual course. I'm going to teach you how to make that data wiggle like a stripper on a brass pole. Alright, so catch me next time. Hit like, subscribe if you did, and the next video is going to be about what actually is happening inside the computer on your motherboard. So stay tuned for that. Thank you.